All right. I'm going to try and talk loud enough so you can hear me, and not so loud that it kind of blanks everything out. Making this video specifically for Dorothy. Super proud of Dorothy because she decided that she's going back to school and she's going to become a nurse, and she had to take a math class, and it's been a while, so she's in college algebra, so it's going to go real fast. It's going to go from pretty much, what everything you learned in grade school, junior high school, and high school, all in kind of, 2 weeks, and then on to the new stuff. So here we go. You're gonna have to excuse me if I go a little bit fast because it's 7:20 in the morning, and I've got a couple things I got to do today too. So the first thing that they wanted you to do with this one is they wanted you to go ahead and reduce this fraction. Probably the easiest thing to do here, because these numbers are a little bit larger than what we're normally used to dealing with. Is to just notice that they're both even numbers. You have 136 as an even number, and 240 as an even number as well. Sorry, I just want to make sure I have small words in writing with a crayon. Okay, so I would start by dividing by 2. Another thing you can notice is if you want to check if the number is divisible by 4, all you have to do is look at the last 2 digits. So I know that 36 is divisible by 4 and 40 is divisible by 4. So that's a little bit of a fast trick, but for now, let's just stick to going ahead and dividing both of these by 2. So 136 divided by 2 is 68, and 240 divided by 2 is going to be 120. Again, we got even numbers, right? So we can divide again by 2. 68 divided by 2 is going to be 34. 120 divided by 2 is going to be 60. Oh, look, we got even numbers again. 34 divided by 2 is 17. And 30 divided by 2 is 30. 60 divided by 2 is 30. So, yeah, that's it. So we divided by 2, divided by 2, and divided by 2. What that means is that if we had done this originally, well, 2 times 2 times 2 is 8. So what that means is that the biggest number we could have seen that goes into them was actually 8. And if you have some free time and you want to do this, 136 divided by 8 is 17, and 240 divided by 8 is going to be 30. Again, once you see they're even numbers, depending on how good you are with noticing patterns and things like that, this is a pretty straightforward thing. Divide by 2, divide by 2, divide by 2. Good? All right, moving on. Number 2, they wanted you to, 2, 3, and 4, they wanted you to add, subtract, multiply, and divide some fractions, okay? So just remember that multiplying and dividing is actually usually easier than adding and subtracting. I know that sounds counterintuitive, but that's you learn how to add and subtract first. Remember, when you add and subtract, you have to get a common denominator, preferably the least common denominator. The first thing you want to do with this one is you want to go ahead and you want to change this into an improper fraction. I know they spent a lot of time in grade school making sure that you know how to use mixed numbers. I guess mixed numbers are important, but the further you go on in math, the more that you just really work with improper fractions. So the first thing I say you want to do is say, this is 7/18, keep that. And remember, if I want to change a number to from a mixed number to an improper fraction, I'm going to multiply here, I'm going to add here, and I'm going to keep my denominator. So the denominator of 12 stays the same. 12 times 3 is 36. 36 plus 5 is 41. Good? Okay. And now we need to get that common denominator. So again, we want the smallest number that 18 and 12 go into. Again, any number will do, but preferably the smallest number. It'll stop you from reducing later. So the smallest number that 18 and 12 go into is 36. So in order to make 12 36, I have to multiply times 3. So if I multiply the bottom by 3, I multiply the top by 3. 18, to make 18 36, I got to multiply by 2. So multiply by 2, multiply by 2, right? Well, now I'm going to get a new problem. I'm going to get, we're not doing here. I'm going to get 14, right? So 2 times 7 is 14. 2 times 18 is going to be 36. And over here on the right side, 41 times 3 is, my brain hurts, 123, I think. 123 over 36. You're going to go ahead and you're going to add those two things together. So 14 plus 123 is going to be 137. Sorry, guys, early in the morning. Okay, over 36. I'm pretty sure 137 is a prime number, so I don't think you have to go any further than that. I also don't believe the problem says to change it to a mixed number, so if it doesn't ask you to change it back to a mixed number, hold on, let me just go check the paper. If it doesn't ask you to change into a mixed number, don't. It's just one more place you can make a mistake and lose some points if this were a test or a quiz or something like that. But I don't believe it. Hold on. Check. It just says, no, we're on number 2. Simplify the answer if necessary. That's simplified. That's it. You're done. Good. So on to the next one. Okay. Same thing here. I got to go ahead. I'm going to multiply and add. I'm going to multiply and add. You don't have to do this, but I just generally found that it's the most straightforward way to explain to people how to do this. So 6 times 12 is 72. 72 plus 7 is going to be 79. If I make any computational errors, sorry guys. 2 times 5 is 10, right? 10 plus 4 is going to be 14 over 5, okay? Again, I got to go ahead and I got to make myself a common denominator. Here, the smallest number, the 12 and 5 goes into is 60. Good? So essentially what you're going to do is you're going to multiply 12 times 5 and 5 times 12. So here, just keep in mind, if you ever are struggling a little bit to find the smallest number that they both go into, you know, the least common denominator, you can always just multiply these by each other. So whatever 5 times 12 is, that's a number that the 5 and 12 go into. So you saw in our last example that 36 was a smaller number, but if I was stuck, I could multiply 18 times 12. You're going to end up with some bigger numbers. You can have to reduce at the end, but it will work. So you'll get a common denominator, just not a least common denominator, okay? Good? So here, sorry guys, usually I work vertically. I was trying to save some space here. So 79 times 5, again, if you want to have some fun times, you can go ahead and do that. 79 times 5 is going to be 395, which should make sense because that's 5 less than 400. Over 60 minus, well, 14 times 12 is going to be 168 over 60, and 395 minus 168 is going to be 227 over 60. Again, I don't know that you can reduce that. Maybe double check. 7, 2 is 12, no, 9, 10. I don't believe that that's reducible by anything, but you can go ahead and check on your own free time because I got to get this done, right, guys? But we're moving on. Okay, you're multiplying. Now, listen, normally your rule is just multiply across the top, right? Multiply across the bottom. But 15 times 21, especially if you don't have a calculator, is, you know, probably a little bit difficult. Also, notice here you're going to have to reduce this at the end, right? These are both at least divisible by 5, maybe something bigger like 15. One of the things you can do is you can reduce beforehand. So you can mix and match from this column and this column. So I can choose something like 15 and 10 and reduce those, and 6 and 21 and reduce those. Or even for this one, just even 6 and 15, those are both divisible by 3. And if you reduce beforehand, what you're going to do is you're going to have smaller numbers, and you're not going to have to reduce at the end where you might have large numbers where you don't recognize the patterns, okay? So what I would do here, I'm going to go ahead and reduce 6 and 21. Well, 3 goes into 6 2 times, and 3 goes into 21 7 times, okay? And then over here, I'm going to reduce by 5, right? 5 goes into 10 2 times, 5 goes into 15 3 times, okay? And now what I get is 2 times 2 on the top, 2 times 2 is 4, and on the bottom I get 3 times 7 is 21. Which is, you know, it's the same thing that we got before. I mean, before we got as our answer, we got 60 over 315. Just, again, you could reduce these, right, and then divide by, you know, say something easy to start with, 5, right? That's going to be 12, and 315 divided by 5 is going to be 63. And then, again, if you notice something else, oh, this is also divisible by 3. You know, so I can divide by 3 on the top and divide by 3 on the bottom, right? And you're going to get exactly what we got. You're going to get 4 over 21, right? But again, listen, if you know your times tables, this shouldn't be bad. And if you know that numbers end in 0 and 5, that are divisible by 5, this shouldn't be hard either. But I mean, a lot of times it's a little bit easier to do it beforehand, work with smaller numbers. And frankly, you're not going to make computational mistakes if you're multiplying. Now, I have a calculator in my hand. If you're taking college algebra, chances are you don't. So, keep your numbers as simple as possible, okay? Here again, we got to change these to improper fractions. Before we do this, you don't have to, but I strongly advise it. 8 times 4 is 32. 32 plus 3 is going to be 35 over 8. Okay, divided by 3 times 3 is 9. 9 plus 2 is 11. So this becomes 11 over 3. Good? Now our rule for division, now remember, this is 35 divided by 8 divided by 11 divided by 3. Okay, so this is division divided by division. So typically the rule that we have is we're going to keep the first one, change this to multiplication, and flip the second one. So you do call this keep, change, flip. Okay? Whatever, you can call it whatever you want, but we're going to keep the first one. Okay, so the first one is going to be 35 over 8. We are going to change to multiplication, and now we're going to say 3 over 11. Okay? Here in front, there's actually nothing to reduce, right? 3 and 8 don't reduce, 35 and 8 don't reduce, 35 and 11 don't reduce. So frankly, we're not going to have to reduce this at the end. So 35 times 3, straight across the top, is 105, and 8 times 11 is 88. And you can keep that right there, okay? Big thing, what we did up here with crossing out, you cannot do here. You cannot do here. No, 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 no. But here, you can do it, okay? So you have to change this to multiplication before you start eliminating things. Okay? All right, moving on. Keep time. All right, so they want to know which number is bigger, okay? Well, think about your number line. Remember, bigger, smaller. Sorry, okay? Okay, so now, remember, any positive number is bigger than any negative number, okay? So if we looked at negative 14, negative 14, negative 14 will be somewhere here, negative 15 will be somewhere here. Which one's bigger? Negative 14 is bigger, okay? Number 7. This is a little bit trickier. They're both positive numbers, so not quite as tricky there. But one of the things you do want to do is you want to go ahead and make them have a common denominator. It's much easier to compare fractions with a common denominator, okay? So 5 and 6 both go into 30. Good? So I multiply this by 6, this by 6, this by 5, this by 5. Okay, that's going to yield us a new problem. That's going to be 24 over 30 and 25 over 30. Now they have a common denominator. You can pretty much ignore the denominators. 25 is bigger than 24. Done. Okay? This last problem, we don't care about any of these matching numbers until we get down to the decimal point. So the 8s are the same, the 5s are the same, the 0s are the same. 8, 5, 0. Next number, I have a 0 here, I have a 2 here. This number is bigger. Okay? So just keep moving from left to right until you find a number that's not the same, then compare those two numbers. Cool? Moving on. All right. What's the opposite of 37? A negative 37, positive 37. That's easy. Negatives, opposites are two numbers that add up to 0. So negative 37 and 37 add up to 0. Am I still recording? I hope so. Oh, 13 minutes. We got to go. All right. So number 10, absolute value. Okay. These are special parentheses. Okay. So one thing is before you do anything that happens inside your absolute value symbols is order of operations wise inside parentheses. Okay. So this is going to be 18. The absolute value of 18 is 18. The absolute value of negative 3 is positive 3. The absolute value of negative 10 is positive 10. Remember, you don't flip the sign. You don't make positives negatives and negatives positive. Everything just becomes positive. Okay? So now all I have left now is addition subtraction, so I'm working from left to right going across. Okay? So 18 plus 3 is going to be 21, and 21 minus 10 is going to be 11. Please go to 11. Okay, here we got two different things. It's important to note that these with parentheses and without parentheses mean two different things. Okay, so I'm going to write this in expanded form a little bit. This means negative 1 times 5 times 5. This one means negative 2 times negative 2. Okay, so this one, again, you're squaring everything inside the parentheses. Here, remember your order of operations. It's exponents, then multiplication, okay? So even if you have a calculator, and you can go ahead and you can do this if you want, they will give you two different answers, okay? So this one is 5 squared is 25 times negative 1, okay? This one over here is positive 2 times positive 2. I'm sorry, negative 2 times negative 2, which is positive 4. Good? Negative 25 plus 4, negative 21. Don't make this mistake. So many people make this mistake, okay? I know it's kind of a little bit difficult to wrap your head around, but you know, the more you do these, the easier it's going to become. All right, number 12. I don't even know what I was supposed to. Oh, turn these, I think we're supposed to turn these into fractions, I think? Yes. Okay, we're going to turn these into fractions. I believe, hold on, let me double check. Write each decimal as a fraction or a mixed number and simplify. Okay, so guys, go way back, right? So let's go. It's 5, 4, 3, 2, 1. Tenths place. Tenths. Hundreds. This. Thousands. Okay, and what? 10,000ths. Okay. So these, again, a tenth would be a tenth, a hundredth would be a hundredth, 1,000 would be a thousandths, and a 10,000 would be a 10,000. So it should be 4 tenths, 3 hundredths, 2 thousandths, and then this last one over here would be 1 10,000th. Good? Okay? Any numbers before this is just a number. Okay? So if you're going to make it a mixed number, you just keep that number. Okay? So this one, let's take a look. This is 6 tenths, 2 hundredths, 5 thousandths. 5 thousandths. Okay? So all you do is you take this last number, this one right here, okay, the last number that you have, okay, whatever position that's in. This is 6 tenths, hundredths, thousandths, right? So this would be 625 1,000ths, okay? And now your teacher has gone so far to ask you to reduce this. I'm going to start with 25, because I know the 25 goes into 625, and now the 25 goes into 1,000. So 625 divided by 25 is going to be 25. 1,000 divided by 25 is going to be 40. All right, so there was a bigger number, okay? Well, 5 goes into 25 5 times. 4 goes in the 5 goes in the 48 times, so 5/8. Okay. The more you guys use inches and things like that, the more this will become in. This is 5/8. Okay. Those are numbers you'll recognize if you use them a little bit more. Okay. They're increments of I think it was 1, 2, 5, or 8. Okay. But another day. Okay. This one over here. This is 9, and then 7 tenths hundredths. So 9 and 7 100ths. Okay, so whatever number you have on the outside, right, that whole number right there, that 9, that's going right there on the outside. Then to make your fraction, I go tenths, I go hundredths, so that's 7 hundredths. Good? All right, now you can't reduce that. Good, moving on, I'm going fast. Okay, then I want you to turn these into percentages. Okay, now on a good day, you just go ahead and plug this into a calculator, okay? So remember, percent means out of 100. So number one, if you can make your denominator 100, your life is going to be super easy. Here, you can. It's 400. So how do I make 400 into 100? I divide it by 4. And very conveniently, this top number, remember what we said before, if the last 2 digits, in this case, are divisible by 4, the whole thing is divisible by 4. So 316 divided by 4 is 79. 400 divided by 4 is 100, so this is 79%. Good? All right. Okay. There are a couple of ways to do this. If you need some clarification, I'll go ahead and do that for you. Okay. This one over here, number 1 is going to be greater than 100%. It should be 300 and something percent because you have 3 as a whole number. Okay? So this will be a huge growth, and I know people think of percents as something, they can't be greater than 100, but it can. Oh, 5/8. Does that sound familiar? It should. 5/8. 5/8. Oh, it's 0.625. Isn't it? There it is, right there. Yes, 5/8. 0.625. So can I make this 3.625? Absolutely, I can. Absolutely, I can. Good. If not, you just take take 5 and divide it by 8. How many times does 8 go into 5? Well, it doesn't. Well, how many times does 8 go into 50? 6, I believe, right? All right, well, what's my remainder? My remainder is 2, right? How many times does 6 go into 20? 8 go into 20? Twice. What's my remainder? 5. I'm sorry. How many times 8 go to, my remainder is 4, right? Okay. How many times 8 go into 40? 5 times, and there's your fraction. Okay, so just divide, keep adding zeros after the decimal point. Here, if you want to turn a decimal into a percent, okay, all you got to do is divide by 100, okay? So dividing by 100, a faster way is say I have 1, 2 zeros here, I have 1, 2 zeros here, okay? So the zeros will tell you how many spaces to move. So this will be 362.5%. Okay? I know I'm going a little bit fast. So if you have specific questions about those, let me know and I'll go over them individually. All right. They want you to, all right, listen, I'm using the calculator, guys, because I only have so much time here. So 3.89 plus 57.3 is 576.19. This one's going to be 99.324. It's my birthday, 324. Minus 88. I hope that's a 426. Bad handwriting. It's going to be 10.898. And over here, don't forget this is multiplication, right? No symbol means multiplication. 0.14 times 2.53 is going to be 77.67. Okay, so they want you to round to the nearest. Is that right? Oh, I added. I'm going to say that doesn't work. 75.14. I told you guys the number of multiplication, right? It's going to be 190.104. Okay. So remember tenths. This is the tenth spot. Okay. So when we're rounding, you go to the number before it. Okay. So again, what is it saying? The number before it. The number after it. Okay. I'm sorry. The 9 that's after it. Okay. Go ahead and take a look at that number. If that number is 5, 6, 7, 8, or 9, then you need to bring the number in the 10th spot up. People get so locked into this rule. What is 19 closer to? Is 19 closer to 10, or is it closer to 20? Right? Well, it's closer to 20, right? So this becomes 576.2. Okay, but it's closer to. We don't write that last 0 because we rounded it to the nearest 10th. Okay, here to the nearest 100th. Okay, so here's 10th. So this is the number we want to round to. Okay. One's a little bit tricky because this one's actually going to go up twice, okay? So we go before it. 8. 8 says that this number is going to go up. Well, 9 goes up to 10, okay? So when I go up to 10, I got to go ahead and I got to bring that next number over. So what's this going to become? 10.90, and it's very important that you put that 0 there. You measured that 0, you rounded to that 0. Make sure you write it there. Don't leave it out. I know normally we left it out. Like we left it out here. Because we didn't need it. Here, since we're rounding to the nearest 10th, we want to show to the nearest 100th, we want to make sure that we put that 0 there to show that we measured. All right, moving on. And the last one, they want to the nearest thousandth. So here, it's tens, hundreds, thousands. So look before. 2 says stay the same. In other words, 42 is closer to 40 than it is to 50. So it's going to be 190.104, and you can stop right there. All right. Non negative parentheses negative 2 squared. All right, so start by this. Negative 2 times negative 2, like we said before, is going to be positive 4. Negative 4 is negative 4. Okay? Good. That'll be important when you guys start evaluating functions later on in the semester. Don't worry, it will come up again. Number 20. Okay, so combining like terms. They all got the same x. They all have the same exponent of 2. Therefore, I can add these things together. You do exactly what it says. Okay? Okay. Negative 5 minus 13 plus 8. Negative 5 minus 13 is going to be negative 18x squared. Keep the x squared plus 8x squared is going to be negative 10x squared. Good? So they're like terms. You do with the coefficients. In this case, your coefficients are negative 5, negative 13, and 8. You do exactly what you normally would do. As long as they qualify, that they have the same variable, the same exponent, you just do whatever operation it's asking you to. All right, moving on. 21. Okay, so here we can mix and match. I cannot add these two together because they are unlike terms. Okay, but I can add 7x and negative 8x and negative 12. right? Those all have a single x raised to the first power. Now you can mix and match. I can say, oh, let me add these three together, and then let me add these. Until you guys get good at this, one of the things I would suggest is go ahead and rewrite these so that they're nice and easy in a row. You just have to remember to bring the signs with you, okay? So this one right here, this negative sign had to go with this. This negative sign had to go with this. And the positive sign here came with this. I guarantee you that's why your professor, your teacher, whoever, made this the way it is, okay? So 7x minus 8x is negative x, right? It's negative 1x, but we don't write the 1. If you want to, you can write the 1, okay, until you get used to it. But as my esteemed colleague, Professor Gain, used to tell me, it's like wearing socks with sandals. You can do it, but you really shouldn't. Negative 1 and negative 12 is going to be negative 13x, and 4 plus 17 is going to be 21. Good? All right, moving on. Going fast, going fast, going fast. Here, again, you can't simplify. Normally we go parentheses first. There's nothing in here to simplify. Okay, there's nothing in here to simplify. So you have to do the distributive property. So we're going to have to multiply this to both, and then actually we have to go ahead and distribute this negative sign to both. Okay? Because remember, we're not just subtracting 5a, we're also subtracting negative 14. Okay? So essentially, here I'm going to multiply 7 times 2a, well that would be 14a. Remember, you're allowed to multiply unlike terms. You are. So that's 7 2a's, well, 14 a's, right? Think of a as something you can hold in your hand. If I had 2 markers, and I had 7 packs of 2 markers, I have 14 markers. Okay? Minus 21. Okay? So 7 times negative 3, negative 21. Here, in order to get rid of these parentheses, I have to make sure I distribute a negative to both. You're really distributing a negative 1, okay, but that's for another day, okay? So this will be minus 5a plus 14, okay? Essentially, you flip the signs. The negative 5a becomes positive 5a, the negative 14 becomes positive 14, okay? Now we can go ahead and we can combine our like terms. So I have 14a minus 5a minus 21 plus 14. Well, 14a minus 5a is going to be 9a, my favorite road to drive on. And negative 21 and positive 14 is going to be negative 7, and that's as simple as you get it, right? I can't combine a's with anything else that doesn't have an a. All right. Yeah, just look at this and gives you a headache, huh? Okay, so remember, everything has to be the same, okay? So this and this are a like term, right? I have a b squared c, a b squared c, okay? This and this are like terms, okay? Because this has an a squared bc, this has an a squared bc. All right. Oh my God. There we go. I break that? Okay. So let's go ahead. Right here, this is just saying plus and negative. If you want to say plus and negative, that's all good with you. The simpler way to write plus and negative is just to say subtraction. Okay, there's nothing inside here to simplify. It's a plus side on the outside. You can drop those parentheses. This is actually, something you wouldn't write this way. You would actually write negative 7 abc squared minus 35a squared bc, okay? So what we can do is we can go ahead and we can say, we can drop this and just make this subtraction problem, okay? So again, let's go ahead, I can say 10ab squared c minus 7ab squared c, right? These two, right? And then I can rewrite these two, plus 2a squared bc minus 35 a squared bc. 10 minus 7, again, you're keeping the a, b squared c. That's not changing. 10 minus 7 is 3. Okay? Here, I have the same thing. I'm keeping the a squared bc, and 2 minus 35 is going to be negative 33. Don't write plus and negative 33. Okay? That's not something we do. 2 minus 35 is negative 33. Good? All right. Okay, so same thing here, distributive property. There's nothing to simplify here. You have two unlike terms. But since 18 is multiplied, and it is because there's no symbol, I need to multiply 18 times both of these numbers. Well, 18 times 1/2 is 9y. Okay? If you forgot that, remember, it's 18 times 2, 18 times 1 divided by 2. Okay? 2/3 of 18 is going to be 12. That's you right there. Okay? Again, just multiply. You guys should know how to multiply fractions by now. Keep the signs all in order. And just remember, you can't add or subtract things that are unlike terms, but you are allowed to multiply them. 9, 40, 7, 49. Oh, we go in. Okay. Here they want you to do some substitution. X is -4. Y is 2. Z is -3. Okay? 29 minus parentheses -4. Okay? Especially when you have two negatives in a row there. Make sure it's inside parentheses. Times 2 times -3. Okay, I'm going to do this one way. You have a couple different ways you can look at this. Again, that negative can go here, right? Remember, it's not the distributive property because there's no addition here. This is all multiplication. So you just multiply left to right, okay? So I know a lot of people are more comfortable, so I'm going to leave this just how it is. I'm going to say 29 minus. Well, -4 times -2 is going to be -8 times -3, okay? Good. -8 times -3 is going to be positive 24. Okay, since there's nothing else to simplify there, I could drop the parentheses, right? Then -8 times -3 is 24. 29 minus 24, 5. All right. Got a bunch of stuff plugged in here. 3, right? Minus 3 times 3 times 5 minus 5. Okay? All right. So nothing to simplify here. Take the 3. Here, now I have 3 times 3. 3 times 3 is 9 times 5 minus, well, again, nothing to simplify here, right? Drop the parentheses, okay? Again, what else do we have to do? Multiply, right? We got to multiply here before we decide to subtract, okay? So this is 3 minus 45 minus 5. Well, 3 minus 45, sorry, it's going to be -42 minus 5. -42 minus 45, -47. All right, moving on. 5 parentheses 2 times -1 minus -6. Again, double negative. Make sure you're inside parentheses there. Okay. Okay. Minus. Okay. Again, -6 squared. Okay. Careful again with your parentheses. All right. So then this parentheses are added. Good. All right. So again, let's start with the inside parentheses. But -2 times -2 times -1 is going to be -2 minus, again, -6. Be careful there. Double negative. We'll get to that in a second. Good. Minus. Okay. And again, since this is another set of parentheses that can work on this over here, -6 squared is going to be positive 36. Good. Well, -2. Again, double negative means we're going to add this, right? So this actually becomes 5 -2 plus 6. Minus 36, okay? -2 plus 6 is going to be 4 minus 36. 5 times 4 is going to be 20. 20 minus 36 is going to be -16. All right. Okay, order of operations, okay? Working inside here first, okay? And then we have to go left to right. This is not normally how we'd write a problem like this, but whatever, it is what it is. Leave that, leave that, leave that, and just like that, okay? Here, I know so many people have this inside their head. What you should really think about it is this, okay? You don't do multiplication and then division, okay? Multiplication and division are really the same operation. You go from left to right. Same thing with addition and subtraction, okay? They're the same operation. Honestly, if that's all you have, it's not going to make a huge difference in your answer, but I mean, I think it does here. It's too early in the day. 5 divided by 30 divided by 5 is 6. Okay? 6 times 2, 12. Okay? Again, had you done it the other way, so the answer is 12, that is our answer. But again, so many people get caught up in that PEMDAS rule that you would have done multiplication then division, which is wrong. Which in this case we got you 30 divided by 10, which is 3, which is not the right answer. Okay, so again, a lot of you guys will see these questions on like Facebook and online, and people tell me all the time, like, why is this the wrong answer? It's like, because you're doing it wrong. That being said, we don't like this. You'll get that later. Okay. All right, here. I think that's a multiplication. I hope that's a multiplication step. I think that's a multiplication step. So we're going to pretend it is. Okay. So first thing, exponents. Negative 8 times 9 plus 0 over 4. Okay. Next thing. What's 0 over 4? It's 0. Negative 8 times 9 plus 0. Don't write that. Okay. You don't need to write that. Okay. You can just leave that off. But for now, we'll leave it on. Okay. We'll pretend like it is. Negative 8 times 9 is going to be negative 72 plus 0 over 4. That's negative 72 plus 0, so that's negative 72. Okay, I hope I wrote that right, guys. All right, oh, God. All right, so here again, our exponents first. 54 divided by negative 3. Again, inside parentheses is going to be 9, right? That's negative 3 times negative 3. Minus 28 divided by negative 7. Okay, again, we're going to divide here, right? 54 divided by 9 is going to be 6, right? 4 divided by 9, 6, okay. Minus 28 divided by negative 7, okay? Now we got to divide over here. You could do these at the same time. You could do these two at the same time, but for here I'll break that 2 steps. 28 divided by 7 is going to be negative 4. 6 plus a negative 6 minus a negative 4 really means 6 plus 4. Your answer is 10. Is that it? Okay. Here we're working inside out, right? Okay, so 18 plus 6 bracket 20 minus 5 7 minus 4 is 3. Okay. Still inside those brackets. Now we got to do the multiplication. Remember, multiply before you go ahead and subtract, right? 18 plus 6 times 20 minus 15, close brackets. Again, still inside those parentheses. 18 plus 6 times, I'll keep inside brackets. The brackets are just parentheses. 5, right? Next one. 6 times 5, right? This is multiplication here. 6 times 5 is 30. 18 plus 30 is going to be 48. Okay. Anything on the top parentheses, anything on the top of the fraction, automatically in parentheses. So I have to do the whole top first and then do the whole bottom first. So you can kind of work with these simultaneously, okay? So the first thing you want to do is that multiplication. So 5 times 4 is 20. So this becomes 15 minus 20. Since they're both in parentheses, you can do the bottom at the same time. 17 minus 12 is going to be 5. 15 minus 20 is going to be negative 5 over positive 5. That is negative 1. Okay. Again, you can simultaneously do the top and the bottom because you can't actually divide them until you're done with both of them. So it doesn't really matter which one you do first. You can do them at the same time. That it? Oh my God, we're done. Done. Okay. Listen, if you have specific problems, let me know. I know I was going fast there, but it's we're 38 minutes in the recording, so I hope you actually take the time to get this far. If you do, good for you. Good way to wake me up in the morning. I'm going to get a cup of coffee and teach my students. Good luck. God bless.